Good day, guys. We are now gradually getting into theorems of the cycle. So this one is theorems of the cycle. So this problem, the main theorem we are testing here is the theorem that says a line from the center of a cycle through the midpoint of the chord is perpendicular to the chord. So what is a chord? Any line from the circumference to the circumference without passing through the center. So this theorem says if you take a line from the center of a circle through the midpoint, then it must be perpendicular. So this is the midpoint because this side must be equal to this in length, then that will be 90 degrees. So that is the main theorem we're targeting today. So problems of this theorem, always to handle problems of this theorem, you must know that at the end of the day, you combine it with the Pythagoras theorem to be able to solve your problem. So in this question, we're told that CD, the chord, is 50 centimeters. OE is X, so I can put it there, that OE is X. Then AE is 3, I can also put it there, that AE is 3 centimeters. Then we have to determine the length of the radius. So the radius, by definition, is any distance from the center of the circle to the circumference. So OC is the radius, as well as OB. So as well as OA. So we need to know the distance of the length of the radius. So whatever you have to do here, don't forget the Pythagoras theorem must step into area. So to get the length of the radius, I need to extract a triangle from that diagram. So the triangle I'll be extracting will be OCE. Then I apply my Pythagoras theorem to that triangle. So let me extract my triangle OCE. That is my triangle OCE. There is E there, where we are told this is X. There is O here, and there is C. So that is it. Now, this triangle is supposed to be a right angle triangle by virtue of the fact that a line from the center of the circle through the midpoint of a chord must bisect the chord, must be perpendicular to the chord. So this is the midpoint because these two marks are telling us that CE is the same length as ED. So that immediately tells me that I have every right to go to this diagram and put my angle 90 there according to that theorem, since the line from the center of a circle through the midpoint of a chord is perpendicular to the chord. So that makes this triangle the right angle triangle, and which can therefore accommodate the Pythagoras theorem. To go further, we are told that CD is 50, and if the whole of that length is 50, and this is the midpoint, then therefore this is 25, and that is 25. So this gives me this one as 25. Then OC, according to our diagram, OC is the radius, and again OA is the radius, because the radius is the distance from the center to the circumference. So that therefore means OC is the same thing as OA. So if OA is X plus 3, then OC will also be X plus 3. So in my right angle triangle, that is what I get. So each time you find yourself with a problem that involves this theorem of a line from the center through the midpoint is perpendicular to the chord, or a line from the center that is perpendicular to a chord bisects the chord, that's another way of stating it, then you know that you must create a right angle triangle from your diagram and then apply a Pythagoras. So we're going to apply our Pythagoras there, which says OC squared is equal to OE squared plus CE squared. So OC, from what I see on my triangle, is X plus 3 squared is equal to OE by X squared. Then CE is 25 squared. So that is what I get. Then I will open the bracket. If I am squaring this, In my own simple way, I'll just take x, I square it, that gives me x squared. I take 3, I square it gives me a 9. Then in the middle, I'll take 2 times 3 times x, which gives me 6x. So that is my own fast way of helping my students do this expansion fast, even though you can still choose to do what you are familiar with in your high school by taking x plus 3 to x plus 3. You see x times x will be x squared, x times 3 is 3x, 3 times x is another 3x, 3 times 3 is a 9, then this one will take you to 6x. So that is how you can do it if you want to take all the time in the world. But usually whenever the power is 2 and there are 2 terms, the fastest way to do it is to take the first term, you square it, it takes you there. Take the second, you square it, it takes you there. Then in the middle, you just take the power 2 times the first term times the second, you put in the middle. So if I go to the other side of the equation, I'll get my x squared, 25 squared is 625. So it's now time to solve for x. So that from there, I can then get my radius, because actually from my diagram, my radius should be x plus 3. So I can't get the radius without knowing my x. So if I pull like terms together, this one going there, x squared will cancel, then this one going there will subtract, so I will be left with 6x on the left, because x squared will cancel, x squared is equal to 625 minus 9, I guess it should be 616. 625 minus 9 is 616, so that is 616, and therefore if I need x, it should be 616 over 6. What does that give me? 616 divided by 6, that gives me 102,667. So I get 102,667. So this is the value of x, and therefore from my diagram I can see that OA is the radius. So my radius R is OA, which is x plus 3, and that will just be 102,667 plus 3, and that gives me 105,667 centimeters. So guys, you see how we succeeded to determine the length of the radius in that diagram. So we'll switch to the next problem, which is more or less something of that same nature. It's dealing with the same theorem, that a line from the center of the circle that is perpendicular to a chord will bisect the chord. So this diagram has 2 chords, AC and DF are chord. You see there are straight lines leading from the circumference to circumference without passing through the center, so they call them chord. And we are also told here that that OG is perpendicular to both chords. So if a line leaves the center of the circle and is perpendicular to a chord, then obviously it bisects the chord. That is to tell you that AB is the same length as BC, which is 9. DE is also equal to EF, which is 6. So in this question, what are we doing? We are determining the length BE, the distance from B to E. So with this theorem, you can't work without cutting off a triangle from the system. Then you apply your Pythagoras there, and it takes you through. So just by analyzing the question, if I need BE, I will certainly be calculating OE, which is the longer distance, minus OB. Now, where do I get OB? I use triangle OED and apply my Pythagoras. Then for OB, I will use OBC and also apply my Pythagoras. So I would like to start with OBC, since I already know 12 and 9 in that triangle, so I'll extract it from my original diagram. So that is my OBC. So this is 12, this is 9 for my OBC. So in that way, if I need OB, I use my Pythagoras, which says OC squared will be equal to OB squared plus BC squared. So OC, you are at 12, so we've got 12 squared. OB, the person we are looking for, then BC, you are 9. So in that case, OC is 144, OC square is 144, equal to OB square plus 81. So if we make OB the subject of the formula, OB will be equal to the square root of 144 minus 81, since 81 has to cross to make 144, since they are like terms, it will be a negative. Then if I subtract and I take my square root, I will see my OB squared. So I will see my OB squared, then I take the square root, then I get OB. So I'm taking the square root of 144 minus 81. That gives me 3 root 7. And decimals is 7,937. So this is 7,397. And then no, okay, there are no units. It's okay like that. So I succeeded to get the distance OB. So if I can also get OE, then and subtract OB from it, I'll get BE. So to get OE, I need triangle OED. So I'm cutting off triangle OED from my diagram. So that's my diagram. So this will be a right angle, that is O there, this is E here, this is D there. So that's my triangle OED. Then I need the dimensions around it. OC is the radius, as well as OG, as well as OD, because they are the distance from the center to the circumference, as you can see. So if OC is 12, it means OG is 12, and OD is 12. So that helps me to see that this is 12. Now, what else do I need? I need DE, and this is where we need the theorem that a line from the center of the circle through which is perpendicular, because you see the perpendicular signs there, to a chord bisects the chord. So it means if this side is 6, then that side should be 6. If this is 9, then that should be 9. So we'll say our DE is a 6. So in this case, you can get OE using the theorem of Pythagoras again. So OD squared is equal to OE squared plus DE squared. OD, you are 12. OE, we are looking for you. DE, you are 6. Then 12 squared, you are 144. OE, we are still searching for you. 6 squared, you are 36. So this therefore tells me that OE is equal to the square root of 144 minus 36. Since 36 is a like term to 144, crosses that side, it will be negative. Then you take the square root. So we're looking for the square root of 144 minus 36. That gives me 6 root 3, which in decimals is 10,392. So it gives us a 10,392. So we have succeeded to get OA, we have succeeded to get OB. Therefore, if we need BE, it should be OE minus OB. Our OE is a 10,392. Our OB is a 7,397. So if we do this calculation, we should be able to see our BE 7,397. So this tells me that my BE is 2,995. So guys, that is how we apply that theorem of the circle. Thank you very much.